In this video, I'll talk about the vector equation of a line given one point on the line and the direction vector. The video is going to be in two parts. In the second part, I'll talk about vector equation of a line given 2 points on the line. It is instructive and very important to note that when writing the vector equation, the most important thing that you have to look for is the direction vector. The direction vector. Now, in this case, we are told that find the vector equation, the Cartesian equation, and the parametric equation of a line passing through the point A, 1, -2, and it is parallel. So this gives us the direction vector. Our direction vector is minus I plus 3j. To solve the problem, our solution is we are given A, 1, -2. And let's call the direction vector B, and that is I plus 3j. I have tried to put this on a diagram so we can see how it looks like. So I'm using Geogebra. This is a free online software. This is the direction vector. It is parallel to this line. From the origin, we have our vector A, and that is the point 1, -2 on this diagram. And the vector B has -1, 3. This is the point, -1, 3. And you find the direction from E to F. So these two lines are parallel. The red line AR is parallel to the vector B. Now we find an arbitrary point R on the line, which we are going to label as vector R. To get to this point, vector R, which is an arbitrary point on the line we want to look for its equation, we can move from O to R directly. On the other hand, we can also move from O to A and then A to R. A sketch of the scenario is shown here. So we can have O, A, move from O to A, and then A to R. Take note, we are saying that this is an arbitrary point on the line. So in vector form, we can write OR, vector OR is equal to OA plus AR. Again, take note of the movement and the position of O here and its position there, the position of R and its position there, and then lastly the position of A and its position there. I move from O to A and then from A to R. That is vector addition. From the diagram, we are saying that let OR be equal to small r. This is shown in here. And OA be equal to the vector A. We know that the position vector of OR can be written as X, Y from the diagram. This is what we have here. And we are given that OA is 1 minus 2. We can also deduce from the diagram that if two lines are parallel, then one is a scalar multiple of the other. That is the main idea. So we say AR is parallel to the line B. That is the direction vector. That is what we're told in the question. AR parallel to the vector B. And let's denote this scalar lambda times B, where lambda is in R. We can then write our vector equation from OR equals OA plus AR. These are vectors. So we show the direction of the vectors. Now we have said that OR is R and OA is A plus AR. We are saying that it's a scalar multiple of B. So we write lambda B. And this is the vector equation of the line. Any point on this line can be located with this vector equation. We can also write it in this form: x, y is equal to 1 minus 2 plus lambda minus 1, 3. I'm taking minus 1, 3 from the vector B. Now, this is the vector equation of the line. The second question says we should find the parametric equation and the Cartesian equation. First, let's find the parametric equation. So I'll first solve the III before solving the II. The parametric equation is obtained from the vector equation. X is equal to 1 plus minus lambda. I'm taking the first component, the x components, and y is equal to minus 2 plus 3 lambda. These equations are called the parametric equations. Let's label them 1 and equation 2. They are the parametric equation. Parametric equation because they involve the parameter where lambda is in R. Lambda is a real number. The last thing is to find the Cartesian equation. And this is how we write the Cartesian equation from the parametric equation. From equation 1, we see that x is equal to 1 minus lambda. This implies that 1 minus x is equal to lambda. From equation 2, we also see that y is equal to minus 2 plus 3 lambda. This also implies that y plus 2 is equal to 3 lambda. And we can write y plus 2 over 3 is equal to lambda. Now, because these two equations, equation 4 and we call this equation 5, are all equal to lambda, we can equate equation 4 and 5. If we do that, then we have 1 minus x is equal to y plus 2 over 3. This is the Cartesian equation. We can go ahead to simplify. If we simplify, we have 3, 1 minus x. This is equal to y plus 2. Further, we can say 3 minus 3x. This is equal to y plus 2. 1 is equal to y plus 3x is the Cartesian equation. If you are not restricted, you can still leave your answer in this form, and it is the Cartesian equation of the line. In the next lesson, I'll talk about how to find the vector equation, the parametric equation, and the Cartesian equation of a line given 2 points on the line.